Hello guys, welcome back to a Drooper Looper video. Today we will be going through yesterday's Paper 3 higher tier EdXL GCSE Maths paper. And we're going to go through the final 10 questions, the hardest questions. I know many people found it hard, so the purpose of this video is to let you see where you went wrong, what you should have done, and I'll also pause at the start of each question so you can retry it if you want. So make sure to like and subscribe, and without further ado, let's get started. Here is question 14. This is the reconstructed question. Pause now if you want a chance to retry it. Okay, so in order to find the area of a triangle, well, we're always taught at school that it's just half times base times height. But the height is this height, and we don't know the height here. We know two of the sides, and we know an angle. So here is where your GCSE knowledge comes in. In order to find the area of a triangle, we have the formula half AB sine C. Now what does this mean? Well, in a triangle, you have these sides A, B, C, and the opposite angles A, B, C. And so, the area is A times B times the sine of the angle in the middle, and then you halve it. So in this case, we're given 8.3 and 9.8, and the angle in between them is 35. So this is simply equal to a half times 8.3 times 9.8 times sine 35. And you can use a calculator to work this out, and this comes out to 23.3 centimeters squared. Alright, now on to question 15. I'll give you a chance to read the question, pause if you need, and try it for yourself. Okay. So in this question, you're either picking a blue bead or a red bead, and you replace the beads back. And this is important because the probability will be the same every time you take a bead. So first, we need to find the probability of pulling a blue bead or pulling a red bead. And because there's 10 beads in total, there's a 7/10 chance of taking a blue and a 3/10 chance of taking a red. And so she takes 3 beads. Show that the probability of Anna taking at least 2 beads is 98/125. So what we need to think is, how could she take at least 2 beads? Well, she could take a blue, and then another blue, and then another blue. What is the probability of this? Well, if you have all of these 3 events happening, then you multiply the probability. A common mistake is that people add up the probabilities. But no, if you have B and B and then B, you multiply the probabilities. So the probability that Anna takes 3 blue beads is equal to 7/10 times 7/10 times 7/10, which is 343/1000. Anna could also take a blue, and a red. And the probability of this is 7/10 times 7/10 times 3/10, which is 147/1000. And now we see that in the other possibilities, so blue, red, or blue, and red, blue, blue, and then blue. By the way, the matter in which Anna pulls these matters for the probability. The order matters here because these three things, they all result in Anna pulling two blues, but the order matters, and so they have distinct probabilities. If you notice that this is 7 over 10 times 3 over 10 times 7 over 10, and this is 3 over 10 times 7 over 10 times 7 over 10, you notice that this is exactly the same as this, except the numbers are in a different order. But as we know, multiplication doesn't depend on the order, so these are both 147 over 1000. And now, these are all the possibilities. We just add them together. So when you're saying the probability of A or B, you add up the probabilities. So we can do 147 over 1000 times by 3, and this is equal to 784 over 1000, which simplifies to 98 over 125. Question 16 shows us a cylinder and a cone, and the base radius of the cone is 8 centimeters, and the total volume of the shape is 640 pi centimeter cubed, and we're given that the vertical height of the cone is 3 times the height of the cylinder. So, calculate the vertical height of the cone. In this question, we need to do some algebra. So, if we let the height of this cylinder be h, then the height of this cone is 3h, because it's 3 times the height of the cylinder. So what is the volume of the cylinder? Well, we know that the volume of the cylinder is equal to, it's the area of the circle times by the height, so pi r squared h. And we know r is 8, so this is equal to 64h pi. Now, what is the volume of the cone? We know that's equal to, it should be a third pi r squared h. But this is a reconstructed paper, so it's not the actual paper. We reconstructed it ourselves, so there might be mistakes. So the volume of the cone is a third pi r squared h, but it's actually 3h because that's the actual height of the cone. And so this is also equal to pi r squared h, and so this is also equal to 64h pi. So if we add these up, we get 128h pi equals to 640 pi. And here we're just adding the volume of the cylinder and the cone. The pi's cancel out, and h is 5 if you do 640 divided by 128. But that's not the height of the cone, that's the height of the cylinder. So the height of this cone is 5 times 3, which is 15. So 15 is our answer. Question 17. We're given an equation and we have to solve it. So pause if you want to try. With algebraic fractions, you just have to treat them like normal fractions. So we want to make the denominator the same. So if the denominator is the same, well then let's make it 3x minus 1 times 3x plus 1. And so what goes on the top? Well, let's take 5x over 3x minus 1. Now, how do you convert this into a fraction with denominator 3x minus 1 times 3x plus 1? Well, in order to go from the first fraction to the second fraction, we're just multiplying top and bottom by 3x plus 1. So we have to multiply the top by 3x plus 1 to give us this. If we do a similar thing, we get minus 2x 3x times 3x minus 1. And so now we've made this into a single fraction. This is equal to 1. So what we can do is we can multiply the denominator to get rid of the fractions. This is actually a difference of squares, although you can manually multiply it out. So if we manually multiply it out, we see that this is 9x squared, this is minus 3x, this is plus 3x, and then minus 1 times 1 is minus 1. And the minus 3x and 3x cancel out, and we just get 9x squared minus 1. And what about on the right hand side? Well, we get 15x squared, which is 5x times 3x, plus 5x times 1, which is just 5x, minus 2x times 3x, which is 6x squared. And now you have to be careful because it's minus 2x times minus 1. Two negatives make a plus, so it's actually plus 2x. And now we get 9x squared plus 7x equals the 9x squared minus 1. The 9x squared cancels out, and we get 7x equals to minus 1, and x equals to minus 1 over 7. Okay, question 18. 100 students were asked about whether they liked coffee, tea, or hot chocolate. And there's some data given below. Construct a Venn diagram based on this information. Okay. So, first of all, let's just fill in the obvious things. 32 liked all drinks, so the overlap between all of them is this region here, so we can put 32 here. And 15 liked coffee and hot chocolate but not tea, so that's this region, so 15 goes here. And now we have to think a bit more, because it says 43 liked coffee and tea, so that's this region here. This region is 43, but we already have 32 in the center, so we have to do 43 subtract 32, so that's 11, and that goes on the top. 39 liked tea and hot chocolate, so that's this region here, so we have to do 39 minus 32, which is 7. 67 liked coffee, and coffee is this whole circle here. So, we have to do 67 minus 11 minus 32 minus 15. And if we use a calculator, this turns out to be 9. And 28 people liked hot chocolate, so that's this circle at the bottom, is meant to say 58 people. Yeah, this is 58 people. I apologize. And so if you do 58 subtract 15, 32 and 7, this gives us 4. And if we look at the last condition, 5 like tea only, and so we put 5 here. However, we're not done, because there is a sneaky trap. There are people who don't like any of the drinks. So we're told that 100 students were asked, but the sum of the numbers don't add up to 100. If you add them up, they add up to 83. So the number on the outside is 100 minus 83, which is 70. So that's how you do this question. It's a bit fiddly, but if you think about it carefully, it shouldn't be too hard. Okay, the second part is that someone is selected at random. If they like coffee, what is the probability that they like hot chocolate? And this is a very simple question, because 67 people like coffee. So that's what we're choosing from. And 47 of them, which is this region right here, 47 of them like hot chocolate. So that's 47 over 67. And you should leave it as a fraction because that's more exact than a rounded decimal. There is a stack of paper. The height of the stack is 10.4 centimeters to the nearest millimeter. The sheets of paper are 0.17 millimeters thick to two significant figures. Find the upper bound for the number of sheets in the stack. We need to think about the upper bound and the lower bound, each of the values given here. But basically, if we want the upper bound, so first, the number of sheets is the height of the stack divided by the thickness. So if we want to make the number of sheets as big as possible, then we want the upper bound of the height of the stack and the lower bound of the thickness. Because if you're dividing by a lower number, you'll get a bigger result. So, what is the upper bound of the height of the stack? Well, 10.4 centimeters to the nearest millimeter. Well, let's convert this into millimeters. The lower bound is 103.5 and the upper bound is 104.5. Because any number 104.5 and above will round to a greater number. So 104.5 is the upper bound. And I may see people saying, okay, but 104.5 already rounds to 105. And that is true, but any number, so a number just below 104.5 will round to 104. So 104.5 is the lowest number which will round to 105. So it's the upper bound. So this is why you may see in an earlier question we had to fill in the gaps for the bound. So we can write this as we use the less than or equal symbols here, but we only use the less than symbol here. Okay, anyways, the upper bound of the height is 104.5 millimeters, and the lower bound of the thickness, that's 0.165 millimeters. So if we do 104.5 divided by 0.165, this gives us 633.3 recurring. However, that's not the answer because we can't have a third of a paper, so we want the biggest whole number. And we would round down normally, but here we definitely want to round down because this is the theoretical maximum, so we cannot be going over this number. So the biggest number, which is less than 633.3 recurring, the biggest whole number is 633. Okay, we're moving to the last 4 questions now. This is a circles problem. Angle A there is 80, angle ODC is 43. So what is angle OBC? I'll give you a moment to think about it. Immediately, we see this very distinctive looking shape. It kind of looks like an arrow. So this should immediately evoke the circle theorem that the angle subtended at the center is double the angle subtended at the circumference. And so what does this mean? This means that angle DOB is 2 times angle DAB. And so this is 160 degrees. But next, we have that opposite angles in a cyclic quadrilateral add up to 180 degrees. And it's very important that you write these out because it says name any circle theorems used. And so this is 100 degrees. And so angle OBC is equal to 360. Remember that the angles in the quadrilateral add up to 360 degrees. And then you subtract all of these and you get 57 degrees. Okay, on to 21. We have these simultaneous equations, but it looks kind of intimidating because the first one has x squared and y squared. So how do you think we should approach? Okay, so with these quadratic equations, you always want to be using a substitution. So here, if we use y equals to 2 minus 3x, then we can substitute it into the above equation. And now this is good because we've literally just eliminated one of the variables. So now all you have to do is to make this into a quadratic and solve it. So 3x squared plus 2, and what is inside here? Well, you can check this for yourself, but it is 4 minus 12x plus 9x squared. If you have any questions, just ask in the comments below. This is equal to 3x plus 8 minus 24x plus 18x squared equals to 44. And if we simplify this a bit, we get 21x squared minus 24x minus 36 equals to 0. Now, this seems quite hard to solve, but if you notice that all of these terms are divisible by 3, we can divide this by 3. Here you can use the quadratic formula, or you can spot that you can actually factorize this, like this. So now, you get that x, or 7x plus 6 equals to 0, or x minus 2 equals to 0. So we're going to think about each of these cases. First of all, if x is minus 6 over 7, then y equals to 2 minus 3x, and if we plug this into our calculator, we get 32 over 7. However, in the other case, if we get x equals to 2, then y equals to 2 minus 3 times 2, which equals to minus 4. Now, this is something very important. You shouldn't write out your equation or your solution like this. Why? Because this is suggesting that this is a valid solution, and it's not. All solutions here come as pairs of solutions, not any combination of these two values. So what you should do is say something like x equals to minus 6 over 7, y equals to 32 over 7, or x equals to 2, y equals to minus 4. Here we have a circle C with center 0, 0. A tangent to circle C at point P has the equation 3x minus 2y equals to 52. Find the coordinates of point P. If we draw a circle, it's centered at 0, 0, and we know a tangent is like this. So first, it's a good idea to write this in the form y equals to mx equals c, because this gives us a gradient. 3x minus 2y equals to 25 equals to 52. You can write this as 2y equals to 3x minus 52, and y equals to 3 over 2x minus 26. And this tells us that the gradient is 3 over 2. Now, here's the trick. If you join the center and the point of tangency, that is perpendicular to the tangent. And if it's perpendicular, we can work out its gradient. So, this tangent line has gradient 3 over 2. We know that perpendicular lines, their gradients multiply to minus 1. So the gradient of this line is minus 2 over 3. And this is very helpful. If you think about it, this line is just y equals to minus 2 over 3x, because it goes through 0, 0. And now we can plug this in into the above equation right here. So we can say 3x minus 2, and we use this substitution that we have here, and this equals to 52. And we know this will give us the value of p, because this will give us a value of x, which lies on both of these lines. And if we simplify this a bit, we get 3x plus 4 over 3x equals to 52. So 13 over 3x equals to 52, and x turns out to be 12. If x is 12, then we can plug this into here, and y is minus 8, because it's 12 times minus 2/3. Okay, we are now on to the last question. This is one of the hardest questions on GCSE papers. It's a vector question and is very fitting. So let's get started. If you want to try it, pause the video now. Okay. This should say 5 to 3, like this. Okay, there's some things we need to talk about in vectors. First of all, if this is a vector, let's say C, then something going in the same direction of it will be a multiple of C, and this is just a constant. The second thing is, and by the way, this constant is the ratio of the length. So this length is k times this length. And the second thing you need to know is that if you have A and B, then this is A plus B. Similarly, if you have something like this, A, B, C, then this resultant vector is A plus B plus C. And with that, we can now begin our vectors question. So first of all, I think we should try and find the vector Mn. In order to find Mn, well, it looks like we're going to need Mo, OB, and Bn. And Bn is related to BC, so let's find BC. We know that BC equals to BO plus OA plus AC, because of this concept I was talking about earlier. And BO is minus 3b, because if you go backwards, then you just do the minus of the vector. OA is A, and AC is 2b. So this is A minus b. So BC is A minus b. Good. Now if it's 5 to 3, then if you think about it, it's 5/8 of the way along. So Bn equals to 5/8 BC, and this is 5/8 A minus B, which is 5/8 A minus 5/8 B. What is MO? Well, MO is minus half A, because it's half of OA and it's going in the opposite direction. So now we can work out what Mn is. Mn equals to Mo plus OB plus Bn, which equals to minus half A plus 3b plus 5/8 A minus 5/8 B. And so we get that Mn equals to an 8th B, or an 8th A, plus 19 over 8b. I'll leave this on if you want to take a screenshot, because I will be rubbing this out. We have that Mn is an 8th A plus 19 over 8b. Now, we're going to try and calculate AP. So here's what we're going to do. We're going to say that MP is a constant times Mn, because they're a straight line. And so this is equal to an 8xa plus a 19 over 8xb. And now we know that MA plus AP equals to MP. So AP equals to MP minus MA. MA is just half minus half of A. Actually no, MA is just half of A. So this is equal to an 8xa plus 19 over 8xb minus half A. And this is equal to an 8x minus a half A plus 19 over 8xb. And now this is the clever bit. We know that AP is a multiple of AC, and we know that AC is 2b. So AP should have no A coefficients, but it should just be a multiple of B. So we can deduce that an 8x minus a half is equal to 0. And so an 8x equals to a half, x equals to 4. And if we substitute this in here, this gives us 19 over 2b. So what do we obtain? We get that AP equals to 19 over 2b. So CP minus 2b, this gives us 15 over 2b. So AC to CP equals to 2 to 15 over 2. So what is K? K equals to CP over AC, which is 15 over 2 over 2, which equals to 15 over 4. Let's put this in a box here. So I hope you found some of this useful. If you did, make sure to like and subscribe and leave a comment.